In this video, we continue our work looking at setting up and simplifying the difference quotient. So we're now going to look at the example when our function is the square root of x. So again, just a reminder, difference quotient looks like f of x plus h minus f of x all over h. So for us, we have our f of x, I already written out here as the square root of h. So what would f of x plus h look like? Well, now into the previous x part of the function, we are going to input that x plus h. So wherever we saw an x before, we're going to input an x plus h. So for s, f of x plus h is the square root of x plus h. All right, so number one thing that we want to do here is then set up that difference quotient. So using our form for the difference quotient here, we first have f of x plus h, which we just computed was the square root of x plus h. Then we're going to subtract f of x, so the square root of x, and that's going to be all over h. So first, looking at the difference quotient here, we want to think about how we can simplify things. So a technique when having a difference quotient of this form, where we have these radical symbols or square roots in the numerator, is a technique called rationalizing the numerator. I'm going to write that out just so you have that vocabulary. Rationalize the numerator. So that is the technique we use to simplify this difference quotient. So let's go ahead and go through that technique. One thing I will warn you about is that it's going to look a little bit more messy before it looks cleaner. So just keep that in mind as you continue working through this problem. Okay, so here's the technique. So what we do is multiply by the conjugate of the numerator. So the numerator has these two radical symbols and a difference between them. So we are going to multiply by that conjugate, which is the same term, square root of x plus h and square root of x. But now we're going to add instead of subtract these two. And we're going to see why we do this here in a moment. And now I can't just go on multiplying whatever I want in the numerator. I have to do the same in the denominator. And that's because I'm allowed to multiply by 1. That doesn't change the overall expression. And if I am multiplying by something over something, where these things are the same, then that's equivalent to multiplying our original difference quotient by 1. Okay, so again, I said it was going to look a little bit messy before it looks cleaner. So bear with me as we multiply out these two, this new conjugate. And just so we have that notation or vocab here as well, this is called the conjugate of the numerator. And so conjugate, it's a fancy word. You might see it come up in your other math classes, or maybe you've seen it before. But it's essentially what we had started with, and then a different, the opposite sign here. So if we started with a negative, then we're using a positive. Okay. So before multiplying that out, I want to give you a little bit of insight as to why we are doing this. So our original difference here, we could simplify that as an a plus b. A minus b. So some term minus some other term. So if we multiply by those same terms, a and b, but now change the sign, what happens when we FOIL this out? And I'd encourage you to even pause the video if you want some more practice using that type of foiling or expanding. All right, so we do the first term, so a squared. Outside terms, we get plus ab. Inside terms, watch this, we get minus ab. And then last terms, we get negative b squared. So what's cool is that these ab's cancel out, and we're just left with the a squared term plus the b squared term. So when we have this situation where we have these two terms, a and b, and we're subtracting them, by multiplying by this conjugate, what we get in the end are those two terms squared and then a plus in between. Why is this useful for us? Well, if we look at the general structure of that original starting form that we had two terms in radicals. So when we multiply by this conjugate, we should be getting these terms squared, which will help simplify things for us. So let's go ahead and do that expanding out, and we can actually see this in action here. I'm just going to go ahead and back up so that we are at a clean starting spot. All right, so let's multiply this out. So what that means, I'm going to multiply this numerator out by this conjugate. And again, I encourage you to pause the video at this point and do that multiplication on your own first, and then we will look at it together. All right, so in foiling out the numerator, we're going to multiply first by those first terms. So we get the square root of x plus h times the square root of x plus h. So square roots would then cancel, and we're just left with x plus h. And if we want a little bit deeper here, if we have square root of x plus h times root x plus h, and that looks like square root of x plus h squared. And so again, we're seeing that root cancel with the square. So we're just left with that x plus h. All right, so that was just a deeper dive there. So what's the first terms? The outside terms are going to be plus root x plus h times root x. Inside terms are subtraction now, so minus x times x root x plus h. And then our last terms are negative root x by root x, which would just become x. So instead of square root of x squared, that would cancel out to just give me my x term. So notice these inside terms here, I have a plus root x plus h root x minus root x plus h root x. So those two terms cancel. So if we clean this up a little bit more, what we're left with here is just a x plus h minus x. And then on the denominator, I'm not going to multiply this h out yet because we'll see some things will cancel. So I have my h times root x plus h plus root x. Okay, so that was a lot of work and calculations that we just did. So if you are feeling a bit rushed right now, please pause the video and rewatch any of those parts so that you're feeling comfortable with where we are at right here. All right, so now we can continue to simplify and clean this up. So in the numerator, I see that I have an x plus h minus x. So what can simplify in the numerator? Awesome, this minus x subtracts that x. So these two terms cancel. So now I'm just left with h over h times root x plus h plus root x. Anything else cancels here? Beautiful, that h in the numerator cancels with the h in the denominator. So we are just left with 1 over root x plus h plus root x. Can we do any more simplifying? Nope, not at this point. So our final answer is this quotient here. One thing I mentioned in a previous video is that often we know we're done when we have no denominator. Here we do have a denominator, but we can see that if we plug in 0, so if h was equal to 0, then it's okay, meaning I can plug in h equals 0. So that's also often an indicator of when we are finished with simplifying. And I'll write that out separately. Also, confirm we are done simplifying if we can plug in h equals 0. So that's just something to keep in mind. And that goes back to what we were explaining in the previous video about where this difference quotient is useful. And that is when some applications you'll see in calculus of computing slopes of what we call tangent lines. So again, you'll see more of that later, but we will just leave that as is, as another indicator of when you are finished simplifying. All right, thanks for watching, everyone.